All right, hello everyone. I just wanted to go through quickly the bigvis sample code. I'm going to be posting this to Blackboard momentarily, so you guys will be able to take a look at this, but thought it was worth going through what I did here. So first of all, the bigvis package, it's meant to easily aggregate large data sets. It's actually created by Hadley Wickham, and he sort of used this as a proof of concept using what's called the RCPP language library, which is integration of C++ into R. So that basically means that C++ being low level, it's being used to really quickly run through large data sets and aggregate them depending on what you would need to do. So up here, there's just a couple of commented out lines that show how to install something like this. So dev tools, you could just install packages, and bigvis itself, you have to install. It's not on CRAN yet, so you have to install it from Hadley's repo. So here we're using install GitHub, and we're grabbing the specific repo. So once you do all of that, you'll be able to bring in the library just like any other library. So I'll get my libraries in, and I also provided just a slice of the Pluto data. So feel free to kind of test it out with that, but obviously part of the main assignment is to bring together the 5 boroughs. So here we brought in the data, and just as kind of a test of bigvis, we'll test if lot area changes with the year of construction. So first, we're just using dplyr to filter the data. So we're going after 1850, and we're only looking at large lot areas, large assessed values, and looking at where a number of floors are not equal to 0. So just some data cleaning. And due to the question, we're looking at lot area versus year built. So those are the 2 columns that we're looking at. So we'll look at those 2. And then let's look at the 5-year averages. So you could see how this works is when you're binning the data, you get to choose the sorts of bins that you're using. So here we're looking at 5-year intervals, and very easily that's just expressed using bin and year built. And defining Z over here is what lets us sort of choose how we're binning this. So we're binning lot area by in 5-year increments. So if we didn't define that, then you can imagine if you just have a single vector and you want counts of sort of ranges within that vector, that's what would happen there. So by defining Z, we're looking at something else by another column. And so we'll do that. And by default, it summarizes by mean, but if you look at the information about the condense function here, you'll see that you could choose other summary statistics. So choose things like count, sum, mean, etc. And that's just should be very familiar in terms of any sort of aggregation that you're thinking of using dplyr, using SQL. You're just choosing what function you're aggregating, you're using to aggregate. So we create our condensed data frame. It's kind of a data frame with some additional attributes, and because this was made by Hadley, he also created ggplot. So it does work really nicely with autoplot. In general, I tend to discourage using autoplot just simply because there's you should be sort of more cognizant of what you're plotting, and ggplot provides the grammar to do that. But in this case, it's usually pretty straightforward, and autoplot takes care of a lot of scaling issues. So here you could see, in order to recreate what I was doing with autoplot, I had to perform some log transforms. So we create that, and then when we autoplot this, we get a nice representation of looking at how lot area is changing in terms of the year that it was built, and count is giving us the number of lots there. Then one more thing, that bins can also be two-dimensional. So here we were binning just one variable, and or sort of binning one-dimensionally. We're binning lot area by year built. But you could also think of this in terms of two dimensions. So here we're going to bring in the movie data set from bigvis. And the way that we're going to bin this, here we had sort of a definition of Z, but here we're just looking at two binned objects. So with this movie data set, we're looking at length and rating, and we're going to see if there's a relationship between those two. And obviously this is also a large data set, so if we just tried to look at a scatter plot, we would get a big jumble of points that wouldn't really tell us anything. So binning is really the way to go to look at something like that. So here we're binning length, and we're also binning rating. And here we just defined what the number of bins are going to be. So and by the way, this find width here, this is sort of the reverse of what we did over here. We were sort of defining the we're looking at the interval. We're looking at 5-year intervals. Here we're sort of finding that width, and we're defining the number of bins. So that's just kind of a little caveat there that you could use the bins both ways. So when we create that bin data, again, we're summarizing with count because we didn't define that. And when we ggplot this, we're going to use geom raster, which is going to give us something like this. And now one thing with this data set is it does contain a lot of outliers, so it kind of gave us something that's not super useful here. And it's pretty easy to, bigvis also comes with an automated way of dealing with outliers. So here we're using the peel function. And when we run that same ggplot over the peel data, we get something that's a lot more usable. So it just automatically took away those outliers. So so there you can see what we did. When you're looking at peel, it's essentially keeping a percentage of the data, and it's removing, ranking it by the density and removing the data points in the least dense areas. It's this works pretty nicely, but I would recommend always thinking about how you're using this. So similar with autoplot, like don't these are useful tools, but kind of take a step back and make sure that you understand what's happening. So don't use it unless you, especially for the Pluto data set, I would recommend taking a look at it first and trying to make some decisions about how you would deal with outliers and other, cleaning of the data set. So that's just one thing to keep in mind. And here, this is just showing that when you are plotting this, it's, here, this is showing you the bin. It's essentially a bin scatter plot. So instead of looking at a bunch of data points that wouldn't really make sense, we could see that we have, where we have regions of dense points. So I'll post this on Blackboard, and this should give you a nice start for the assignment. All right, talk to you guys later.